10 minutes. Let's work. Don't be distracted. Don't look at the time. You have 10 minutes, 9 now. Are you done? You can see the last question. You may say or say out, you're off topping my view. So when you say you can see, I think. All right. Grade 10. Let's say your definition. I'll write the definition. Or also definition. It's a wave. It's a wave where the movement of the particles of the medium. I will do this so that we know it's perpendicular to the direction of propagation. Somebody can also use the direction of the wave. Direction of the motion of the wave instead of saying propagation. Please get that. Get your definitions correct. We also have a session for all the definitions that we did in term 1, and then we have few definitions in term 2, just to deal with properties of chemical and physical properties. Now, let's look at what we are given here, and then we are saying label point B and C. What is B? A B will be our wavelength. Why is B a wavelength? Why is B a wavelength? Is the distance between 2 points that are in phase. Ne? 2 consecutive points that are in phase. These 2 points are in phase and they are consecutive to each other. Can be 2 crests, can also be 2 throats, as long as they are consecutive to each other. That's why we saw it that these are actually wavelength. And what about C? And I think the examiner was not fair there. We cannot label it C. You are giving us a clue. Ne? So I can just continue from it and just say crest. Good. Are we fine? So B will be the wavelength and C will be our crest. And then how much time has lapsed while the wave moved from R to T? How much time has lapsed while the wave moved from R to T? From here to T. What was the statement on top? The statement was saying what? You didn't write the statement. Okay, let's go back to the statement. Because we will not answer the question. What is it? All right. I'm gonna save this. Okay, let's take a look at. You need to make sure that, yes, the diagram represents a pattern of waves with frequency of 30 Hz moving from left to right. So our frequency is 30 Hz. Ne? Please write down that statement. You will need it. Make sure you always read your statements. Let me underline that. We have a frequency which is 30 Hz. And then how much time has lapsed while the wave moved from R to T? Any volunteer? How much time has lapsed? Can somebody define a frequency? What is the definition of frequency? If somebody will ask you, if your grandmother can come and ask you, what is frequency, my child? I hear they say frequency is 30 Hz, but what is frequency?
Number of successive crests passing in given point in a second.
The number of passing a point in 1 second. Eh? So let's say, for example, for this crest to get here, if the frequency is 30 Hz, so it means that we have 30 crests passing through this point in 1 second. So if you ask us about how much time will be last, it means that you are saying you are looking for the period. And we know that the period will be the same as t equals to 1 over f. Don't only use them, but you must understand why I'm using them, right? And then it means that your period will be the same as 1 over 30, and which is going to be 0, 0,033, seconds. So somebody can also say, but it's fine, you can also write it like this. If you want to write it into 2 decimal places, it will be 1, 2. It's going to be 3,33 times 10. You move twice, ne? 1, 2, you move twice. 1, 2, so it's going to be -2 seconds. But if you leave your answer as this, you will also be given full marks. That is recurring. You can also do that, yeah, if you still remember your mathematics, ne? We call this the recurring, ne? And then if somebody can also write, this is the same as 1/30 seconds, I will also give them 2 marks. Make sense? Now, let's take a look at, now calculate the speed of the wave. Let's calculate the speed of the wave. We still have space this side for 2.2.5. The question was say calculate the speed of the wave. I will save this so that you can see the question. All right, we now want to calculate the speed of the wave. What will be the speed of our wave? Or 2.2.4. Let's go to 2.2.4. Are point R and S on the wave in phase? Explain your answer.
No.
No. Point R and S. Let's look at point R. Here's point R. Let's use a different color. Okay, let me use red. Point R. It's at the beginning of the wave. You see? And then point S, it's in the middle of the wave, you see? At the end of a crest, in the beginning of a throw, right? So you are saying the answer would be no. You can also write they are not between a wavelength, eh? Or they are not between 2 points that are in phase. But they are not separated by a wavelength. I will accept that. That's why they are not in phase. If they were in phase, they would make it a wavelength. So you can also say, no, they are not separated by a wavelength. Yes. Yes. Yeah, I wonder if you can say they're not in the same consecutive positions. Then I can take that because we are specific to say that point must come immediately after that one, but it must be in the same position. For example, if I'm in the beginning of the wave, remember this is our full wave. So I'm expecting the next point to be in phase with this one. It must be at the beginning of a new wave, which is here. If this is our crest, it means I'm expecting the next point in phase to be the next crest. For the throws, the same applies. The next one will be my next point in phase. If, for example, I take a point at random, I must check where that point is. Let me just use 2. If I say I want the point in phase with this, I know that it's in the beginning of the way of the crest. I see a crest, okay, just before the first crest end. That's the point. So it cannot be here. It should be where? Somewhere there. And this will be there. Same position in that wave, the blue wave, and is the next one. the immediate one. I can't take any point again. It will only be in place with the next, the previous one. Now let us jump into 3.2.5 very quickly. In 3.2.5, we want to calculate the speed of the wave. So the speed of the wave, what is the formula for the speed of the wave? V is equals to F times lambda. Do we have F?
Yes.
F was how much? 30 hertz. Né? And then, do we have lambda?
Yes.
Which is how much?
4.
4 meters. Okay, so the speed will simply be 30 multiplied by 4, and then our speed will actually be 120. What are the units? Meters per second, because this is in hertz and this is in meters. You must also check the units there. You can quickly write that down, and then we'll move into the next question. Right? Term 1 revision. Can we move?
Yes.
All right. We're going to increase the pace a bit. And then let's give ourselves some time. Now we go to longitudinal waves. We have question 4. Let us try on a new page, not on a new page. Question 4. What we need is the questions. We have 1, 2, 3 marks. I'm gonna give you 4 minutes.